Hi students, all of you welcome. Welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, from today onwards, we are going to discuss utilization topic-wise MCQs. This will be very useful for your all competitive examination. If you have not subscribed this channel, please click on subscribe button and also please share to all your friends. And this series is only for the students who are preparing sincerely. Okay, so let us start the session. Coming to the first question, guys. The range of visible light. The range of visible light. Okay. So the range of visible light is 4000 angstrom unit to 7000 or 7500 angstrom unit. Okay. Here it is generally in case of micrometers, that is 400 nanometer to 750 nanometer. Okay, so 1 nanometer is in the sense 10 power minus 9 meter to 750 into 10 power minus 9 meter. Okay, so this one we can write down. We can add one zero here, and then you will get 10 power minus 10 meter to 7500 into 10 power minus 10 meter. And we know very well 1 angstrom unit is equal to 10 power minus 10 meter. It is also very important question, guys. Okay, very important question. So we can write this one 4000 angstrom unit to 7500 angstrom unit. Okay, so the answer is option B. This visible light, that is nothing but all the WebGR colors. WebGR colors. Okay, so in this, violet having lowest wavelength and red color having highest wavelength. Okay, violet lowest wavelength and red color having highest wavelength, and in between these we have greenish yellow color is there now. It is most sensitive, highly sensitive to human eye. Our human eye is highly sensitive to this greenish yellow color, highly sensitive. Okay, so the answer is option B. Coming to the next question, guys. The color which is having shortest wavelength. The color which is having shortest wavelength. Just now I have given all the WebGR colors: violet, indigo, blue, green, yellow, orange, red. So the visible light spectrum is nothing but 4000 angstrom to 7500 angstrom unit. So violet having the lowest or shortest, red having highest. Okay, so highest wavelength. So that's why red color generally used in case of danger signals. Danger signals, because of the highest wavelength or longest wavelength, it can be visible from longer distances. Okay, red color is having highest wavelength. Okay, highest wavelength. So that means it can be visible from longer length, visible from longer distances. That's why it is used for danger signals. And violet having the lowest wavelength. And coming to their frequencies, frequencies are different, guys. Frequencies are different. Violet having highest frequency spectrum and red color having lowest frequency spectrum. Very important. Highest frequency spectrum is violet, lowest frequency spectrum is the red. Reverse. Okay, so here shortest wavelength is nothing but violet. So the answer is option D. Coming to the next question, guys. The color which is having highest velocity, velocity or speed. Velocity or speed. So just now I have given, and we know the velocity is nothing but wavelength into frequency, guys. Okay, for example, if you can consider violet, it is having lambda is low, but frequency is the higher. In the same way, from violet to, if you can consider red color, it is having highest lambda, that is wavelength is more and frequency is less. One is high, one is low. Here, sorry, one is low, one is high, and here one is high, one is low. So that means what you can say? All are having same speed. All are having same speed. So the speed of light is constant. That color having any color that may be having, that light may having any color that has same speed, but their wavelength and frequencies are only the difference. Okay, so V is the constant. V is the constant. Higher the wavelength, lower the frequency. Okay, but velocity is the constant, or speed is constant. 1 angstrom unit is equal to dash meter. Already we have discussed this one now. 1 angstrom unit is equal to 10 power minus 10 meter. Very, very important question. So the answer is option A. Okay. Students, I have given, I will give my Telegram link in the description box. So all of you try to click on the link and join in the Telegram channel to download this PDF. Okay. So, or you can search with the SSC JE Electrical by Suneel sir. Then you will get my Telegram channel, and in that also you can download. Okay. So just click on the description box of this video. Coming to the next one. Human eye is most sensitive to radiation with a wavelength of about dash. Just now I said in all the WebGR colors, our human eye is more sensitive to this. Our human eye is more sensitive to these colors. Okay, so this is the 4000, this is the 7500 or 7000. In between these two, we have 5500 na, in between these two. Okay, so greenish yellow color having 5500. Our human eye is more sensitive of this wavelength. Okay, coming to the next question. Units of the plane angle. Units of the plane angle. Options are given as radians, steradian, meters, and angstrom unit. Angstrom unit. What is this plane angle, guys? For example, if you can consider any one arc, not a solid one, just one arc. Here, the angle to this arc is considered as the theta. Consider as the theta, and this is considered as the radius, or then plane angle. Plane angle is denoted as this, theta, and this is considered as the arc. Now this arc by radius, okay, this arc by radius is nothing but you can say the plane angle. Arc by radius is nothing but you can say plane angle. So the units are nothing but you can say radian. Radian is the unit of plane angle. Okay, very, very important question. Plane angle units are nothing but just radians. In case of solid angle, so solid angle case, here in the plane angle, just we have taken one plane. In case of solid angle, we have to take the solid. Solid means solid having the area. Solid having the area. So if you can consider any one area, and here the angle is nothing but omega, and this is the radius. This is the radius. So from this one, solid angle is denoted as the omega, that is area by radius square. Okay, so that means area is A by radius square means R square. Radius square means r square. So units are nothing but steradian. Okay, so all of you try to remember plane angle, just plane. Okay, that is theta, arc by radius. The units are just radians. Okay, just radians. In the same way, solid angle is nothing but solid case. Arc is replaced with area. Okay, this is nothing but area. Area by radius square. Units are steradian. Units are steradian. So the answer is option B. Coming to the next question. The largest solid angle subtended at the center of the sphere is dash. Subtended at the center of the sphere is dash. What is the largest solid angle? So coming to this largest solid angle, that area by radius square na. So largest in the case total area we can consider of the sphere is nothing but 4 pi r square, and radius area by radius square na r square is going to be cancelled out, that is 4 pi. The units are steradian. 4 pi steradian, so the answer is option D. 4 pi steradian, so the answer is option D. Coming to the next question. Units of luminous flux is dash. Units of luminous flux. Luminous flux units are nothing but lumens. Luminous flux units are nothing but lumens. And Webers are nothing but magnetic flux. Maxwell also magnetic flux unit. Okay. What is this luminous flux denoted by pi r f? Okay. So it is nothing but rate of luminous. Luminous flux is the rate of luminous energy. Rate of luminous energy. Okay, luminous energy. Or we can also define as the energy in the form of light. Energy in the form of light, or in the form of light waves radiated per time or per second. Okay, the energy in the form of light waves radiated per second. So energy per second, or energy per second means rate. Rate means time. Okay, so rate of luminous energy by time. Luminous energy by time is something we can say flux pi. So the units are lumens. Coming to the next one. Units of candle power. Units of candle power. Okay. What is this candle power? That is nothing but total luminous flux lines. Total luminous flux lines per unit solid angle. Per unit solid angle. Okay. So that means you can say candle power, total luminous flux by this solid angle. Okay, so luminous flux units are lumen. Lumen per solid angle is steradian. Okay, so lumen per steradian is nothing we can say candela. Very important. Lumen per steradian is also nothing but can say candela. So the answer is option C. So the answer is option C. Okay. So luminous intensity. Luminous intensity. Units of luminous intensity. Luminous intensity also same like candle power. Okay. So this is also can say luminous flux emitted by the unit solid angle. Luminous flux emitted by the source per unit solid angle. Solid angle. So luminous flux by solid angle means luminous intensity is denoted with the letter I, luminous flux pi, and solid angle is nothing but omega. Okay, so flux units are lumen, lumen per steradian, lumen per steradian. I have given it is nothing but candela. Okay, so candela is also one of the unit of luminous intensity. Okay, or lumen per steradian. Both options are there. So both A and B. So the answer is option C. Okay, so whenever we see the option B, directly we can give the answer B. But lumen per steradian is also one of the unit. So we can give the answer as option C. So here there is a chance of confusion. Okay. Coming to the next question. So here coming to this luminous intensity, if it is the light emitting source, okay, so here it is the luminous flux. Luminous flux, if you can consider a solid area, okay, solid area. So luminous intensity is nothing but that luminous flux pi r f by this solid angle omega. Okay, so that is nothing but lumen by steradian. So or you can say candela, or also nothing you can say candela. Okay, so answer is both A and B. Coming to the next one, in the following which is correct? In the following which is correct? Very very important one, very easy one also. Which is correct? We know very well candle power is equal to lumen per steradian. Nah? From this one, lumen is equal to candle power into steradian in the sense solid angle. Steradian or solid angle. Okay, so can say solid angle. So the answer is option. So the answer is option. Okay, coming to the next one. Units of brightness are lumens. Units of brightness are lumens. This brightness or lumens is denoted by the letter L, that is nothing but luminous intensity by area. Luminous intensity by projected area. Okay, so luminous intensity candela by area means meter square. So candle per meter square. Candle per meter square. Okay, candle per meter square is the unit of luminance or brightness. Sometimes you can also give the Lambert. Okay, the Lambert. Candela per meter square is the brightness or luminance. And the next one, illumination. Units of illumination. Illumination is denoted with the letter E. E is nothing but can say the luminous flux by unit area. Luminous flux by unit area. Pi by area. So that means lumen per meter square. Lumens per meter square. Okay. So lumen per meter square. Lumen is nothing but can say candle power into solid angle or steradian by area or meter square. Okay, by area or meter square. So we can also give this one as lumen per meter square is nothing but can say lux. So illumination units are nothing but can say lux or lumen per meter square. Lux or lumens per meter square. Okay, lumen per meter square. Here the difference is luminance or brightness, luminous intensity by area. So candela per meter square, Okay, and illumination E is nothing but lumen per meter square or lux. Lumen per meter square or lux. Okay, so here they have given lumen per meter square or lux. So then what will be the answer here? Lumen per meter square or lux. So we can say both option A and B are correct. Both option A and B are correct. Okay, and lumen per watt is the unit of dash. Lumen per watt is the unit of dash. So lumens are nothing but light output. Light output. Watt is nothing but electrical input. Am I correct? So lumen per watt, output by input. That is nothing but can say efficiency na. Efficiency. So can say luminous efficiency. Very, very easy question. Luminous efficiency. Okay. So the answer is option D. So the answer is option D. Coming to the next question, guys. Utilization factor for direct fittings lies between dash. Utilization factor for direct fittings lies between dash. It is nothing but a static value 0.4 to 0.6. So coming to this utilization factor is nothing but generally lumens received on the working plane. On the working plane by lumens emitted by lamp. Okay, for example, if you can consider a lamp, so lamp emits the lumens, that is luminous flux. Okay, so emits the lumens. In this, if it is the working plane, this working plane may not receive all the lumens. Some lumens may be deviated. Okay, so the utilization factor, how much of lumens we have utilized. So this amount of lumens we have utilized. So lumens received by the total lumens emitted by the lamp. So generally lumens received always less than that of the lamp now. So that's why here utilization factor is less than 1 for this direct fittings. So it is value having 0.4 to 0.6. If you consider indirect fitting, that is less. Indirect fittings, that will be approximately 0.1 to 0.4 or 0.35. 0.35. So that means option C for indirect, option D for direct fitting. Okay. Okay, students, if you want this PDF, just click on the description box and join in the Telegram. Then you will get the free PDF of this. Okay. Okay, students. Thank you so much. We will discuss remaining in the next session. I think I'm feeling you can share this one to all your friends. Okay, and you can encourage me to take more classes. Okay, thank you so much, guys.